Presentation will be done by both Ian Storey, president of IB Storey, and Brodie Guest, president of Guest Automation. A little bit of the background. So IB Storey was founded in 2001. It has been designated the official rink engineer consultant of the NHL. It is actively engaged with the NHL on enhancing community rink sustainability, both financially and environmental. The Guest Automation, what they've been able to do is really amazing. They support over 125 rinks across North America. They've been able to verify and to demonstrate a cost savings of 40% to those members. Having said that, I'd like to pass the presentation over to both Ian and Brodie. Ian, Brodie, take it away.
Thanks to everyone for joining today. Our presentation is joint because we, Guest Automation and IB Storey, completed a project this year which really highlights one of the key aspects of sustainability. And sustainability and efficiency is, they are linked. It's the combination to really unlock your potential. And it is something that we wanted to highlight, one of the smaller aspects of the things that we had accomplished this year. So I'm Ian Storey, president of IB Storey Inc.
I'm Brodie Guest, president and CEO of Guest Automation.
I'd like to just start briefly with talking about sustainability, because that word tends to conjure up images, particularly environmental or renewables. Those are the two things that when we talk about sustainability for facilities, that tends to be the generally accepted go-to position. But sustainability actually includes a large variety of other issues. Sustainability is not as simple as achieving one number. It is actually a combination of things, and it includes things like inclusion, environmental that we talked about, financial. A lot of people don't think of financial immediately when it comes to sustainability, but it is actually part of the sustainability mix when it comes to facilities. The commute to the facilities, as well as the utility footprint, CO2 emissions in particular when it comes to waste emissions that we are talking about from a facility. That's has also been known in the past as dumpster diving analysis, and some renewables. So we really wanted to zero in on the two things of environmental and financial sustainability, and as being in the backbone of sustainability for recreation facilities. We do highlight in this presentation, we are highlighting some rink engineering results, but this information does apply to all recreation facilities. So the most common question I get, it tends to be around financial sustainability. There's those that think it doesn't belong, and those that think it doesn't have a piece, and those that think it sounds like something relatively new. So I pulled just a couple of snippets of some information that was published some time ago, directly pointing at financial sustainability. So I'll start with the oldest one that I have here. So it's from the Harvard Business Review, published in 1999, a roadmap for natural capitalism. And it was talking about our natural resources and how we're using them in our facilities. So business strategies built around the radically more productive use of natural resources can solve many environmental problems at a profit. Harvard Business Review focusing on some business aspects, but they really made the link between the profitability of being looking at how we're using our natural resources. And that's something that is often overlooked. We think of sustainability investment as being a burden, and in fact, it can be something that is actually of benefit. The other thing I pulled was something from Our Choice, which was Al Gore's book in 2009 regarding a plan to solve the climate crisis. And in chapter 12, I believe is taken from, there is information on how we use energy. Less is more. So their book, Our Choice, is filled with research that they did on everything from population control to supergrids. And so this entire chapter was on efficiency. And their research concluded that improvements in the efficiency with which we use energy offer the biggest opportunities to reduce energy consumption and CO2 emissions, while saving money and increasing productivity at the same time. Efficiency improvements are also far and away the most cost-effective among the solution to the climate crisis and can be implemented faster than any of the others. It is something that is really often overlooked. We tend to want to go to one fix or one thing, but from that standpoint, the efficiency aspect is something that is at the heart of sustainability, and the two are inherently linked. Reducing energy consumption and CO2 emissions. Utilities, generally speaking, provide us electricity as one of the utilities. We often have gas utilities as well, but electricity in particular, we don't think of the pollution that comes from that, but there is an equivalent pollution that the utility has to make as part of its mix, which applies to almost all utilities across the continent. So there is a direct correlation. When we save electricity, we actually save pollution as well. And so that brings us to efficiency. As I mentioned, it is really the key to facility sustainability. So I pulled this from the Carbon Trust. For anyone that's not familiar with the Carbon Trust, it was created by the government in the United Kingdom in 2001. And it is positioned as an organization that is an expert partner for businesses, governments, and organizations around the world, with the belief that environmental sustainability and economic prosperity can go hand in hand as we address the climate crisis. So there, once again, 20 years ago, linking together both environmental and financial sustainability. And from one of the documents that they published, one of their many guides in 2008, they noted that many organizations have environmental policies and know they should reduce carbon emissions from their operations, but miss the opportunity to embed these principles in refurbishment projects. And that, we find, tends to come up particularly in asset management plans when we're talking about a same for same replacement in an existing facility. The assumption is that the new one will be more efficient than the old one, but it's not always the case. So, as I mentioned in the opening, we wanted to profile a project that we have done jointly this year, the West Hand Sports Complex, birthplace of hockey, and in Windsor, Nova Scotia. And the municipality had a very aggressive objective. They wanted to exceed the National Energy Code by 50%, meaning 50% less than code for the National Energy Performance. This required both high performance and energy efficiency. And a bit of a spoiler alert, the facility is operating at 16 equivalent kilowatt hours per square foot. And so to give you some context to go with that, the Energy Star median for that, for an ice rink is 43 equivalent kilowatt hours per square foot. So on that note, I'm going to turn it over to Mr. Guest to provide us some information on one of the things that we leveraged on efficiency, the ice rink energy management control system.
Excellent. Thank you, Ian. The reason we chose to highlight this project is because it's the first integrated thermal plant in Nova Scotia using Opteon. And yes, it actually is in the birthplace of hockey, birthplaceofhockey.com, in case you're not familiar with it. This project was executed in Nova Scotia from Alberta during a peak in COVID-19 cases. So how is this done? Guest Automation's original and current business model is partnering with local companies to support our installation and to provide post-project support and service. Our technology allows us to work, optimize, and service our systems remotely. This project and all of Guest Automation's intelligent rink energy management control systems are completely open source and open protocol. What does this mean for you? It means non-restrictive service and support. Any trained controls person can access, inspect, and modify the system, keeping the system sustainable. It is 2021, and unfortunately, companies are still trying to limit options for their customers in this aspect. This entire facility is on a single open platform, meaning all refrigeration, electrical, and mechanical systems are integrated, communicating and working together, which is extremely efficient. On the left, we have a home page or a landing page. So when the users sign in, they can quickly see an overview of their entire facility, We can see temperatures, we can see alarms, etc. On the right-hand side, we have the ice plant summary page showing the package chiller, the low or the cool side of the system, and then we can see the high or the heat side of the system in red. We can see the fluid cooler, backup water heaters, and other pieces of major equipment. I mentioned integration in the past slide, and quite frankly, integration is so important and is the key to success, really. When we look at this floor plan graphic on the left and we see the energy flow of the system, the R on the left stands for the refrigeration and the refrigeration plant itself. From there, we see it carries heating, cooling, and dehumidification to the rink space. Continuing to move to the right, we're heating the common areas, the offices, the meeting rooms, community rooms. And then furthermore, still passing 100% recovered heat to the turf field, which again, extremely efficient. If the ice is out like it is today, we have smart integrated water heaters to heat only the loads that actually require it from the thermal management system. I'm sure everyone has heard of IoT, which stands for the Internet of Things. This facility is completely integrated with several different manufacturers' equipment, working and communicating together on, again, a single open platform with complete mobility and access from any smart device. No plugins, no apps to download. Quite simply, just simply log on to your browser from any computer, anywhere, to monitor and control your facility. The floor plan graphic, again, on the left shows all temperatures, humidities, air quality levels, and other important points within the facility with a spectrum graphic quickly indicating if temperatures are at, above, or below set point. The top right graphic shows the backup water heating system and the intelligent water heaters I mentioned before. The bottom right graphic shows the main air handling unit with a glycol heating coil in it instead of a traditional natural gas-fired appliance. So how does this facility achieve such a low energy footprint per square foot? Expertly engineered sequences and an industry-leading thermal management system. This TMS is highly complex, yet completely automated and simple to the end user. The thermal management system is always monitoring, calculating, and re-ranking every 10 minutes of operation or every time the ice plant starts up. The TMS is so intelligent, it knows how much heat is available from either the plant or from the backup water heaters, and how much heat is required within the facility. Then it will choose where to direct that energy. Furthermore, it also knows when the next availability of energy will come and will hold off and hold operating equipment that is purchasing more or more energy. Why heat a low occupied area when it's half a degree below set point? Areas like this can afford to drift slightly from set point to heat primary and prioritized areas. The longer a zone is below set point, it will simply get moved up the rank. The zone priorities are constantly changing as the TMS re-ranks automatically. End users simply set schedules and set points just like any building automation system, but then the TMS goes to work. In the main thermal management screenshot we have here, we see in the top left, the TMS system, the thermal management ranking system is enabled, it's green. And in this screenshot for context, showing when we had full heat, full ice plant heat available, we see the ice plant status is on, we see the amount of heat available, we see the live heat load, excess heat, etc. Continuing down the list, we see here, stage 1 of heat rejection is the makeup air heating valve. So essentially the building is almost satisfied. We are rejecting heat to heat the turf field. We're not throwing the heat outside, very efficient. On the top banner of that same screenshot, we see the TMS mode is currently in overheat mode. So again, since the building is almost satisfied, we're taking our excess heat and temporarily increasing each zone set point by 2 degrees Celsius, which when the plant turns off, allowing for these zones to coast back down to their normal set point. causing far less starts and stops of equipment and cycling equipment. Each major piece of equipment in green is enabled, allowed to run, and is ranked based on its heat load and when it will effectively serve again. The screenshot up in the top right, again, shows it's a graphical representation of that makeup air that is, again, rejecting heat, but using that reclaimed heat to heat the turf field. Thank you, and back to you, Ian.
Thanks, Brodie. So we were mentioning earlier at the start of the session, this does apply to recreation facilities. So this is an example where we have artificial ice operation for part of the season. It's a seasonal rink. We talk about how we deal with it in the off season. We're predominantly talking about how we're using heat, but certainly these systems can easily be configured for heating and cooling depending on your climate. The key things with the thermal management system is the intelligence that it knows to try to recycle the energy before it purchases new energy. And it's that recycling effect that is particularly dominant. On the efficiency side of things, that is really key in terms of getting what is called waste out of the system before we talk about applying renewables. So I had mentioned that for that new construction, the municipality had some very aggressive energy goals for this facility in terms of maintaining its sustainability for that municipality. It really fell into what we refer to as a net zero ready facility. So that is really where we look at minimizing the energy consumption through both equipment and efficiency, and that can be applied to existing or new facilities. And so I wanted to profile the emerging trends. We are currently underway with 2 new ice rink constructions in PEI, that's Prince Edward Island. One opening in 2021, one opening in 2022. Those are both being constructed to a net zero ready standard with operating designs at less than 10 equivalent kilowatt hours per square foot. And again, for some context, the Energy Star median for rinks is 43.6 equivalent kilowatt hours per square foot. And from that standpoint, I think it's fairly clear that we certainly need a lot less renewables added to the system in order to go to a net zero or a zero energy rink. So a zero energy building it has a commonly believed definition of being a facility that uses as much energy as it puts back onto the grid annually, thus achieving that net zero. The term net zero is actually used for a variety of definitions in the industry. So you have to be cautious when someone says net zero, that you're not believing it's the generally believed definition, which is not always the case in terms of what is happening or what is being defined. So a zero energy building or a zero energy rink is one where we are putting as much energy back onto the grid on an annual basis as we're taking off of the grid. And these net zero ready constructions put these facilities well within the ability to, in a financially viable way, become a zero energy building or a zero energy rink. So thank you for your attention. If you'd like to know more about that, please feel free to get in touch with us. And I'll turn it back to John.
Thanks, Ian. Thanks, Brodie. I think you did a really fantastic job in identifying the factors of sustainability. We spoke about CO2 emissions, environmental requirements, renewable energy, financial. And I think it's also important to note that we've asked you to go through this process knowing that whether you are a private owner of a facility or you're part of a municipality, what we have learned and realized is that there is a real lack of understanding of the complexity of what's involved in creating an asset management plan and ensuring that it is compliant with the future legislation requirements. So thank you for bringing that to our attention.